Okay, so we want to convert the polar coordinates, 7, 7 pi over 4, to Cartesian coordinates and round our answer to 2 decimal places. Okay, well, if you look right at the top of Module 5, this last module in the course, in the Canvas course shell, I put notes for you. So here's some notes on complex numbers in polar form. Number 1, converting polar coordinates to rectangular. You start with the polar coordinates r theta. X is r cos theta. Y is r sine theta. I want you to see where that comes from. I don't want that to be magical to you. Math is not magical. There's logical reasons for everything. So if you just think about a normal x-y axis, here's x, here's y. If we turn to some angle theta, right here. Let me finish the triangle first off. There we go. So if we make a right triangle, if we turn to some angle theta, it wasn't very neat, was it? There we go, some angle theta. And so this would be the point, and this is a distance r, let's say, right? So this is the point r comma theta. So, well, in fact, you know what? I did that kind of badly. Let's just start with some point right here at a distance r at an angle theta, right? So that would be the point r comma theta in polar coordinates. So starting with polar coordinates, it's not those ones, but in general, some r, some theta. That's how you would find where the cannonball lands, right? You would turn to angle theta and shoot it out a distance r. So that's the point r comma theta in polar coordinates. How would you change that to rectangular? Well, you would just go over and up to that same point. This would be the x and this would be the y out to that same point. So how would you find the x and the y? Well, remember our SOHCAHTOA? Whenever you have a right triangle, you can use SOHCAHTOA. This is a right triangle. Why is it right? Because it goes straight over and straight up. Rectangular coordinates go straight over, straight up, so they make a right triangle. So if I use the sine is what? Opposite. This is the opposite from angle theta. This is the hypotenuse. This side here is the adjacent, right? So the sine of theta is the opposite, which is y over r. It's opposite over hypotenuse. Do you see that? That's just SOHCAHTOA there. So if you take that, put a 1 underneath here and cross multiply, you get r sine theta is 1 times y. In other words, y is r sine theta. That's where we're getting that when we say y is r sine theta. That's just true. If you're at some point r theta in polar coordinates, your y coordinate, your height, must be r sine theta. Likewise, your x coordinate, if I was to come over here, maybe I can squeeze in the x. If we take the cosine of theta, this angle theta, that'd be adjacent over hypotenuse. I scribbled over that. Adjacent over hypotenuse. It would be x over r adjacent over hypotenuse. And again, if you put 1 underneath this and you cross multiply, you'll get r cos theta is 1 times x. In other words, x is r cos theta. So that's where we're getting those. If you just take any point r theta, polar coordinate point, angle theta, shoot out a distance r, your x and your y, your over and your up, your rectangular coordinates, just using SOHCAHTOA, the x will be r cos theta and the y will be r sine theta. That's where those formulas come from. That's all we're doing with those two formulas, is converting from polar to x and y, from r theta to x and y. So let's do it then. So I just recreated the wheel there. You don't need to do that every time. Let's just solve the problem now. So x is r cos theta, x is r, this is r here, whoops, kind of scribbling, this is r, is the 7, the theta angle is 7 pi over 4, so it's going to be 7 times cosine 7 pi over 4. All right. So what is the cosine of 7 pi over 4? Well, you want to use that unit circle. I don't think I have a unit circle handy here, but if you look on the unit circle, how could I tell you? Let me see here. Maybe I could find a unit circle real quick. So maybe I couldn't though. At the same time, I have to go back a long, long way to try to find a unit circle. Let me see if I can. I might be able to. I might have trouble coming up with it here. There it is. Took a little while. All right. Got it. Here's a unit circle. So, angle where we at? 7 pi over 4. So 7 pi over 4 is somewhere. There it is. Whoop, I'm not in the right mode. There we go. 7 pi over 4. This is cosine. This is time we want cosine, right? Cosine 7 pi over 4 is root 2 over 2. So we go 7 times root 2 over 2, which is 7 root 2 over 2, because this is 7 over 1, and just multiplies the top. Oh, looks like they want decimal. So yeah, so you didn't need to do all that stuff. They said decimal. I didn't notice. So just hit the buttons on your calculator. Yeah, you didn't need to look up the unit circle and all that monkeying around I did. You can find that on your calculator. 7 times square root 2 equals about 2. I'm getting 4.9. How many decimals? 2 places. 949. So 95. So 4.95. And then for the y equals r, not cosine, sine theta, according to the formula, r, and then sine of 7 pi over 4. So just hit the buttons on your calculator. Alright, so 7 times the sine of 7 pi over 4. I'm getting minus 4.95. Minus 4.95. So there it is. We found the x and the y using the formula.